Hi, today's lesson is operations with functions as well as composition of functions. Operations with functions is something you have done back in Algebra 1. That basically it means that you can use addition, subtraction, multiplication, and division to combine functions and obtain a new function. So example 1 is simple versions of this concept, and then examples 2 and 3 get more complex. So, example 1, find each of the following as a polynomial in standard form. All right, so before we go on, just want to clarify what that means. A polynomial in standard form, a polynomial is just a string of terms written from high to low power. So if you look at the functions listed in example 1, all of them are polynomials. It's a string of terms with addition or subtraction written from highest to low power. All right, example 1a says we want to do f of x plus h of x plus k of x. Remember, f of x just is another way of saying y equals, but the f represents the name of the function and x is the variable that you input into that function. I'm going to color code the functions. So f of x equals 2x, g of x equals 2x cubed plus 4x squared plus 2x, h of x equals x plus 4, and k of x equals 3x minus 1. So going back to 1a again, f of x, so that's yellow, plus h of x, which is blue, plus k of x, which is my pink. We want to add those three functions together. Now, anytime you insert a function, I would recommend using parentheses. You may not need them, but I would start off that way. All right, so I have, I'll change to my pen. So I have the 2 of x function plus, I'm going to add h of x, which is x plus 4. Plus, I'm going to add k of x, which is 3x minus 1. And then we'll start simplifying from there. So we have adding. Now, when you add, the parentheses can disappear. So now I'll drop it. Had you have dropped them to begin with, it's fine. I just wanted to make sure you realize that we were adding three groups together. Adding does not change the groups, so I can rewrite them without the parentheses. And now I'm going to follow directions, which is to write it as a polynomial. This is a polynomial, but it's not in standard form. It has to be written with all the terms combined that are like. So then I'm going to add like terms. So I have 2x and x and 3x, which is 6x. And then 4 minus 1 is 3. And that is your final answer. B, k of x times h of x. So k of x is my pink times h of x is my blue. Okay, so I have k of x is 3x minus 1 and h of x times h of x is x plus 4. So we are multiplying a binomial with a binomial. A two-termed polynomial with two-termed polynomial. In order to multiply that, you can use the box method if you prefer, or you can double distribute. I'm going to double distribute, but you may do the box method if you wish. So 3x times x is 3x squared. 3x times 4 is 12x. Negative 1 times x is negative 1x. And negative 1 times 4 is negative 4. Right, combining like terms, because this is a polynomial, just not in standard form, we get 3x squared. 12x minus 1x is 11x. And then minus 4. And that is your final answer. All right, so the next problem, C, h of x minus k of x. So h of x is the blue function, minus k of x is the pink function. All right, so again, parentheses, because we're inserting a group, x plus 4 minus k of x, which is 3x minus 1. The parentheses were in fact needed on this problem because when you subtract a group, the subtraction side is going to distribute and change the signs of the group being subtracted. So x plus 4 is fine, but then this negative sign distributes into the group and you get minus 3x plus 1. Then adding like terms, we have x minus 3x is negative 2x. 4 plus 1 is 5. Okay, and D, g of x divided by f of x. So g of x is green, and we want to divide it by f of x, which is yellow. So we have 2x cubed plus 4x squared plus 2x divided by f of x, which is 2x. So now you have a polynomial divided by a monomial. And when you have a single monomial in the denominator's position, you can simply take the monomial and divide it into all the terms of the polynomial. Now you don't have to do this, but if you want to, you can split it up like this by showing the division of each term. You can skip over this step and go right to the answer. So then you have to just divide 3 little mini division problems. 2x cubed divided by 2x, well the 2's cancel, and x cubed divided by x is x squared. You subtract powers when you divide. 4 divided by 2 is 2, and x squared divided by x, the powers subtract to be 1, so it's 2x. And this is where you just have to be careful. 2x divided by 2x does cancel, but when you divide, they don't cancel to nothing. When you divide something by itself, it makes a 1. So this is going to be a plus 1, and that's where a common mistake occurs a lot of the time. And then that would be your final answer. All right, the last 4 problems dealt with the g of x and f of x, x meaning to use the equation. On problem E, we have a number. We have a negative 2 here. So this means x is negative 2. G minus x of negative 2 is the same thing as saying g of negative 2 take away k of negative 2. Now you can answer this problem in one of 2 ways. You can subtract the g function and the k function first to find the function that represents that and then plug in a negative 2. Or it's more simple if you just in fact evaluate g of negative 2 and k of negative 2 separately and subtract the outputs. Because when they give you a number here, they really want to know what's the numerical output out. So g of negative 2 means I'm going to plug in a negative 2 for g. And I apologize, I'll use a green for the g. So g is 2x cubed, so that'll be 2 times negative 2 cubed plus 4 times negative 2 for x squared plus 2 times negative 2. And then you would just simply put all of that into your calculator and you would get a negative 4. Then we're going to find k of negative 2. K is 3x minus 1. So k of negative 2 is 3x, so 3 times negative 2 minus 1. You'd put that in your calculator and get -7. And then lastly, to answer our question now, we want to figure out what is g of -2 minus k of -2. Well, we have the two answers. We have the -4, and then we have to minus off the k of -2, which is -7. You put that in your calculator, and evaluate that, and you're going to get 3. And then that would be your answer. All right, so moving on to some more complex problems. Example 2, you have two functions, f of x and g of x. And then they want you to do this really, a lot of things to it. They want us to take the f function, so I'll highlight. They want us to take the f function and then multiply it with the g function, and then minus off the g function squared. So we have a lot of operations going on. We have multiplication, we have subtraction, we have a square power 2, and you have to remember the order of operations. Okay, so order of operations, we definitely want to take care of the parentheses first. Brackets are the same thing as parentheses when you're doing operations. Sometimes when there's too many parentheses going on, we use brackets instead of parentheses so we can distinguish like what group goes with what group. So even though that's a bracket, I technically can use parentheses. I'm going to leave it alone for now. Because I'm substituting a group, I always like to put a group in its own parenthesis. That way, if I have to distribute or have to subtract, I don't forget that the entire group is involved. So there's the f function. Then I want to multiply it with the g function. And then I have to minus off the g function. And that g function, though, is being squared first. All right, so the first thing we're going to do is we need to multiply these two together. Okay, so again, in order to multiply this, you can do the box method or you can just do distributing. We're going to be triple distributing. We take, all you do for multiplication is take each term and multiply it with each term of the other one. So 3x squared times x is 3x cubed. And then 3x squared times -4 is -12x squared. Then you take x and you multiply it with both of those. So x times x is x squared. And then x times -4 is -4x. And then -2 times x is -2x. -2 times -4 is +8. Adding like terms, we have 3x cubed, -12x squared plus 1x squared is -11x squared. We have -4x and -2x is -6x, and then +8. So that is the multiplication group. But we also have to do the squaring group. So the x minus 4 has to be squared before we can subtract it. All right, so what would that look like? X minus 4 squared means x minus 4 times x minus 4. So I need to multiply those two together, and I'm going to do the similar way. I'm going to double distribute. X times x is x squared, and x times -4 is -4x. -4 times x is another -4x, and -4 times -4 is +16. So in the end, we have a minus And then adding like terms, we have x squared, negative 4x and negative 4x is negative 8x, and then plus 16. All right, so the last operation that's involved in this problem is we have to do the subtract sign. And not only that, we have to make sure we write our answer as a polynomial in standard form, which again just means that it's all the terms combined as it could from highest to lowest power. When we subtract, we need to distribute the negative sign. That's why the parentheses keeping the groups together is really important. The 3x squared minus 11x squared minus 6x minus or plus 8 is not going to change. But when you subtract, you're going to bring the negative sign into the group. So it becomes negative x squared plus 8x minus 16. And then lastly, following our directions, polynomial in standard form, I have to combine everything as much as possible and write it from high to low power. So 3x cubed, negative 11x squared, and negative 1x squared is negative 12x squared. Negative 6x and positive 8x is plus 2x. And lastly, we have 8 and negative 16 is negative 8. And that is your final answer. All right, our last problem pertaining to operations with functions. A lot of times these are involved in real life problems, especially the business world. You'll be dealing with a cost function, a profit function, a revenue function, which is exactly what example 3 pertains to. A manufacturing company has developed a cost model. The cost model is that function C of x, where x is the number of items sold. The sales price can be modeled by S of x, which is 60 minus 0.07x. Therefore, the revenue is modeled by R of x, which is how many number of items you sold x times the sales price of each. And then we want to express the company's profit, P, and profit is basically your revenue minus the cost that took to make it. So revenue is the amount of money you bring into of your sales, and cost is the amount of money to make your product. All right, so our question is we want to find P of x. All right, well, P of x is equal to two functions being subtracted. So we need the R function, and then we need to minus off the C function. All right, so the R function, the R function is actually another operation of function. It's x times a different function. So we need to figure that out, and then the C function is equal to this blue function up here. All right, so P of x is equal to R of x. We need to figure out R of x. R of x first. Apologize, I'm going to use green. R of x is equal to the x times the S function. All right, so where's the S function? The S function is right here. It's 60 minus 0.07x. All right, multiplying those two together, I get to distribute. I get 60x minus 0.07x squared. So that's my R function. So now I can answer my question. P of x is equal to the R function, which we just figured out as 60x minus 0.07x squared, minus off the C function, which is 0.75x cubed plus 0.12x squared plus x plus 100. I really recommend highlighting. Word problems can be tricky, but if you highlight the important part, you can then look at colors to help you identify like what you're really working with. Okay, so now we boil it down to just this, an easy subtracting two polynomial problems. I am going to distribute in the negative sign. So 60x minus 0.07x squared stays the same, but then the minus sign here gets distributed. I recommend you distribute the negative sign because I know from experience that a lot of students will forget to subtract the other terms once they get by the first one or two terms. So by distributing in the negative sign, I don't have to worry about going back to that single subtract sign. Now I'm going to go through, and again, polynomial in standard form means to combine everything as much as possible. So I have 60x. Oh, my highest power actually is the cubed one. That was way over here. I'm going to start off with the highest power. That's going to be negative 0.75x cubed. Then my next highest power is the x squared. So negative 0.07x squared and negative 0.12x squared. That's negative 0.19x squareds. Now I can do the x's. So 60x minus x is positive 59x. And then lastly, the negative 100. And that represents the profit function for the company. So they know based on the number of product, what their profit is going to be for that number of product. Okay, so the next topic we're going to get into is going to be new to you guys, and that's composition of functions. Composition of functions is like when you do a chain reaction with the functions. These do happen in the real world. It's when like you have to input something into a function and then use the answer for that into a different function. So for example, example 4, the function c of f equals 5/9 f minus 32. And that gives the Celsius temperature that corresponds to a Fahrenheit temperature of f. So remember, c of f just means that's the name of the function. It's the Celsius function, and it depends on the Fahrenheit temperature. Then we have a function, the kc function, and k of c equals c plus 273. And that gives the Kelvin temperature that corresponds to the Celsius temperature c. Suppose in chemistry class you needed to convert 50 degrees Fahrenheit to Kelvin units. What would 50 degrees Fahrenheit be in Kelvin units? All right, well, the 50 degrees Fahrenheit, that's our Fahrenheit temperature, so that's our F. And what we can do with an F is we can input it into the C function and convert it to a Celsius temperature. So then we have C of 50 equals 5/9 50 for F minus 32. And then you just simply put that into your calculator and you will get 10. And that represents 10 degrees Celsius, although you do not need to put the units on. Our question though is, what is the Kelvin temperature that corresponds to that Fahrenheit temperature? So now that we have the Celsius temperature, we can then use the C right here as our 10 to convert it to kelvins. So we have K of 10 equals our Celsius temperature of 10 plus 273. And that gives us 283 kelvins. So that is a real life example of composition of functions where it's like a chain reaction. In the box below, this is symbolically how it would be written. There's two ways to write a composition of functions. You can either say f of g of x. All right, that's like a chain reaction. Please do not get that confused with multiply. That does not mean multiply when you have one function inside the other function. A multiplication would use a times symbol, or you won't have parentheses inside another parenthesis. Okay, or f of g of x. You can have this little bubble symbol. That also means composition. And it really does matter the order. The order does matter of how you do your chain reaction. Obviously, if you do your chain in a different way, it's going to produce a different outcome. You always do the closest one first, and then that answer gets put into the other one next to it. And you can have a composition of function that involves more than two. It could be 3 or 4 in the chain. All right, so let's go ahead and look at example 5. Example 5 says f of g of 1. Okay, so I will color code again. I'll call the f function green and the g function pink. So when you're doing f of g of 1, you're going to do the closest one first. So that means we're going to do this first. G of 1 means that x is 1, so we're going to input in a 1 wherever the x is. So 2 times 1 plus 3, you can put that in your calculator and you'll get 5. So then what happens is you take that answer and you put that answer into f, and that's the green function. So f of 5, because this answer gets put into there, and then equals, and you put it wherever the x is. So x is right there for squared, so it's going to be 5 squared minus 5. And again, you don't need parentheses in this problem, but I want you to get in a habit of always putting something that you're inputting to a spot in parentheses, because there are times where it will matter. So 25 minus 5 comes out to be 20. The answer is only the answer at the end of the chain, so it's just the 20. You're not going to do anything with the 5. The 5 was used to get our final answer. Okay, B. So g of f of 2 means same two functions, but this time you're going to start with the f of 2 first, because that's the closest to the number. So this is going to be first. So f of 2, we're going to do 2 squared, because that's the f function. 2 squared minus 5, and you're going to get negative 1. Then that answer gets put into g. So we have g of negative 1. That answer gets put in, equals, and then we fill it into the g function right here. So 2 times negative 1 plus 3, and that comes out to be 1, and that's your final answer. All right, C and D just use the other notation. Okay, g of f of 3, still a composition. We're going to do the closest one first, so f of 3 goes first. F of 3 equals, all right, that's the f function, 3 squared minus 5. And you get 4. And then that function gets put into the other function, which is g. So then we're going to go to the pink function, g of 4. Equals 2 times 4 plus 3. And then that gives you 11. And that is your final answer. All right, and last one on this page, we have D is f of negative 2. So that's strange. You're going to actually use the same function twice in the chain. You first start off with f of negative 2. And that will be negative 2 squared minus 5. This is really important that you did in fact use parentheses around the negative 2. If you did not have parentheses around the negative 2, you will get a different answer on your calculator, because your calculator won't realize that the negative is part of the 2 that's being squared. So a negative 2, all of that in parentheses squared minus 5 comes out to be negative 1. If you don't have parentheses, you will get a different answer there, so check how you're inputting that. And then we're going to take that answer and plug it into f again. So f of negative 1, that answer gets put in, equals, same function, so square the x, negative 1 squared minus 5, and you get negative 4. And again, without the parentheses, you will get a different answer, so be careful. All right, we have one last set of notes to do. Example 6 and 7. We're still doing compositions, but if you notice with example 6a, it says f of g of x. So there's no number here. It's an x. This means you want to find the equation that represents the composition. All right, so the first thing you do is start with the g of x. Well, since there's no number, that just means that we're going to take g of x. So g of x, I'm going to color code them again. I have green and pink. I need to take the entire g function, and just like before, we need to plug it into the other one, just like what just like what we would do with a number. So I'm going to take the g function and I'm going to put it into the other one, exactly where you would put in an x. So take g of x, plug it right into f. Okay, so what does that look like? It's going to be x squared. Well, that's where we're going to insert it. So it's going to be something squared minus 5. That g function that's in pink gets put into there. So instead of a number for x squared, it's the whole entire g function that's going to be squared minus 5. This is technically an answer. It's just not in the right form. Going back to the directions, our directions state that we want it as a polynomial in standard form. That means it has to be a string of terms being added or subtracted. This is not a polynomial. So all we have to do is to undo all of this and combine like terms, and then we're done. So I just want to stress that this is an answer, just not in the right form. So how do we undo 2x plus 3 squared minus 5? Well, we're going to do power 2 first, which means that there are 2 of them. I have to multiply by distributing, double distributing. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2 is 6x. And 3 times 3 is 9. And then we have the minus 5 still. And lastly, combine like terms. 4x squared. 6x plus 6x is 12x. And then 9 and negative 5 is 4. And that's the composition of functions of f of g of x. All right, b, g of x means I'm going to take the g function and put it right back into itself. So take the g function and insert it into itself. So I like to start with the g function and leave a parenthesis for all the x's, and then you can go back and fill in the guy we need to fill in. That would be the best way to attack this. So the g function is 2 times x, so that's my fill-in, plus 3. And then what am I filling into that? I'll change colors. I'm filling 2x plus 3 into itself. So 2x plus 3 gets filled in to where there's an x. All right, this is technically an answer, just not in the right form. So I'm going to go ahead by distributing 4x plus 6, and then they have the plus 3. Combining like terms, you get 4x plus 9. Okay, we'll try this 2 more times so you can get the hang of it. This is a little bit hard for students. So last problem, example 7. We have f of g of x is our first problem. I'm going to color code. All right, so we have f of g of x means I want to take the g of x, that's first. I need to fill it into f. So I'm going to start with the f because g of x can't be done anything more with. I'm going to start with the x, the f of x, and I'm going to write it, but leave gaps for all the x's. Then I'm going to fill the g function in there. So the g function gets filled where all my gaps are for x. So I have to fill in an x squared minus 3x plus 8. That was my only fill-in. And now I need to answer the question, again, polynomial in standard form. So I have to simplify this. We have 2x squared minus 6x plus 16 minus 5. And then combine like terms, we get 2x squared negative 6x. And 16 minus 5 is 11. All right, and then last problem. We need to take the f function and fill it into the g function. So I'll start with the g function and leave gaps. I need to do something squared minus 3 times something. So this actually has 2 spots where I need to fill in the thing, and then plus 8. So I fill in the f function in there. The f function is 2x minus 5. And although that is a correct answer, it's just not in the right form. So you will not get full points with the directions. So standard form, I need to undo all that. 2x minus 5 squared needs to be expanded. That means there's 2 of them. I'll start by expanding that. 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2 is negative 10x. Negative 5 times negative 5 is positive 25. All right, then up here, the negative 3 needs to be distributed. So I'm going to keep on going with that. That's negative 6x plus 15. And then we have this plus 8 that needs to be dropped as well. Okay, combining like terms now. We have 5 or 4x squared starts off first, and there's no other squareds. We have negative 10x, and negative 6x. That makes negative 26x. And 25 plus 15 plus 8 is 48. And that is the composition of g of f of x.